So welcome back. Let's continue. So again, I summarize because that's very important. Do not use the words mapper, combiner, reducer. It's misleading. It prevents you from understanding what's going on. You will see it over the internet. Whenever you see it, always ask yourself the question, do they mean function? Do they mean task? Do they mean slots? Do they mean phase? Always ask yourself. And then it will give you clarity of mind, right? So the postcard example should clarify the difference between a split and a task and the way that the tasks are assigned to the slots. It's really important to understand that within the same slot, so for every one of these persons, it's sequential. Every person can only write one postcard at the same time. I don't know you, maybe you can write two with your two hands, but I can't, right? So this is really sequential for every person. And the tasks are also executed sequentially. They go to the next pile, but you don't know in advance what tasks will go where because that's dynamic, right? It's really at runtime that whoever finishes first picks up the next task, okay? So the functions are mathematical. This is just our Java function, a Python function, right? Then the task is a sequential and repeated function call of MapReduce. The combine is special. Then a slot repeatedly and sequentially processes tasks. And as soon as it's done, it just takes another task and takes another task. When there's no tasks left, then it's just waiting until everybody else is finished. It's still sequential. The only parallelism that happens is across slots, because every slot will correspond to one CPU core or virtual core, and it's actually threads, as we will see later, right? For those of you who know what a thread is. And there is parallelism across slots, but within a slot, everything is sequential, one by one, the function calls. For whom is that clear? Who has now a better clarity of mind over what's going on? Very good. This is all hidden, right? This is the physical layer. As a user, you don't even see that. It's good if you know that this is what's going on, but this is all hidden from the user. The only thing you need to take care of as a user is implement the map function, the reduce function, decide where you read from, where you write to, and possibly a combine function. That's your responsibility. All the rest is done automatically by MapReduce. So now I have yet another summarizing chart here where you see the nodes, these are the machines, right? We have multiple slots per machine. Why? Because you know that now we have multiple cores, even your laptops here. Maybe they have 8 cores, 16 cores, right? So these are slots. So we have multiple slots. Every slot can execute multiple tasks one by one, and within the task, it's just function calls. Okay? So this is how it works. And technically, every slot and task is either map or reduce, and typically they are stamped like just like matrix, the red and the blue one. So I put in blue the map slots and in red the reduce slots. Okay. So this is done statically. What is mapping and reducing, that's decided before you run the job in advance. Okay. Then let me finish with a tricky point. Sometimes, some years, some of you notice, actually, I think, I can't remember if this year one of you already noticed, it might actually be. Because I told you that the splits are the blocks. I told you every HDFS block gives you a MapReduce split in general. But there is something that you need to understand here because it's not that easy, right? So we have the map tasks and the reduce task, right? And we split the data, and every split of the data gives you one map task. Now you know these little rows here. At the beginning, I didn't call them that way. But now we know that these are tasks. All of these are tasks, right? These are tasks. So every task has one split, right? Like this. Every task corresponds to one split. And every split corresponds to an HDFS block. Does anybody see the problem? A split equals a block.
So someone said in the room, the block could be bigger than 128 MB.
It's the right direction. Let's make it even more precise. But this is the right direction. You have the right intuition. Let's discuss one at a time. Let's completely forget about MapReduce for a moment, just HDFS. Oh, yes, go ahead. Maybe let's hear you as well.
Values could be split across.
Let me increase the, did we plug it? Yes, we plugged it. Let me increase the volume. Go ahead.
Values could be split across multiple blocks. Like the unit of text that we want to look at could be split across multiple blocks.
I'm so sorry, I cannot.
The value that we want to look at could be split across multiple blocks.
Yes, exactly. The value you want to look at might be split across multiple blocks. Yeah, that's exactly it. That's exactly the intuition. Sorry about the quality of the microphone. But you have the right intuition. So let's get back to HDFS blocks. Forget about MapReduce. HDFS has the blocks to partition the files into 128 megabyte chunks. In HDFS, this 128 megabyte is exact. It's at the bit level. You count 128 megabytes, then you cut it exactly at 128 megabytes. These are just bits. HDFS just sees bits. It doesn't know about records and key values. It just sees zeros and ones. So you count 128 megabytes, bam, you cut a block and start a new block. It could be less, right? It could be less if it's the last block and it has less than 128 megabytes, then of course it's smaller. But it will actually not be bigger than 128 megabytes, but the splits of MapReduce can be. And this is probably what you meant also on Zoom. The splits in MapReduce, they are not based on bits, they are based on key values, right? You have a collection of key values, and every split is a subset of the key values. So a split must end when a key value ends. And now this is exactly what you were saying, is that you have in this block, maybe you have a few thousand key values in the block. And if you now look at the very last key value of that block, it's very likely that it's going to start in that block, but then it will finish in another block. Because you might have the key value exactly on the boundary between two blocks. In fact, almost all the time it will happen. The probability that it's exactly coinciding with the end of the block is very infinitesimal. So we have here a mismatch between the splits that work in terms of records. You partition the collection of records, and HDFS that partitions bits, collections of bits, right? Who sees that now? Okay. And so this is what happens typically. You have a record that's typically within exactly one split, but on the HDFS physical level, HDFS, it's kind of in between. So what happens is that it's a bit tricky physically. You basically kind of sort of assign a split to a block. You say, this is kind of sort of my split, except that there is a few more bits in here in the next block to finish my last key value pair. So it means that if this block, there is a replica of that block on the same machine as you are reading it, that's a local read. But the last few bits, you might have to go over the network and request them from another machine if that block is in a different machine. But you can just make it so that you only ask for the first bits and don't read the entire block, right? So you don't need the whole 128 megabytes, just the first few bits. For whom does that make sense? Okay. But the good news is, as a user of MapReduce, you don't care. This is just taken care of by MapReduce. The engineers of Hadoop and of Google took care of it for you. You just have to know that there is this slight impedance mismatch between the blocks and the splits. Okay, so this is the reality, actually, that every split slightly finishes on a different block every time, which finishes the MapReduce lecture. Do you have any questions on MapReduce? Anything that is not clear that you want me to re-explain, to repeat? On Zoom, anybody? This is your opportunity to have me repeat things. Or you can repeat on YouTube, right? You can repeat the video and come back and accelerate it, 125, and so on. Okay. Well, if there's no questions, I will just proceed with Apache Spark then. So let me move on to the other sides.